Welcome to Maths for You channel. Another past question in binomial expansion. Question number 3, part A. Fully expand p plus q to the power of 5. P plus q to the power of 5. The expansion 5 c0 p to the power of 5 q to the power of 0 plus 5c1 p to the power of 4. 5 minus 1 is 4, q to the power of 1. 5c2 p cubed, 5 minus 2 is 3, q to the power of 2, plus 5c3 p to the power of 2 q to the power of 3, plus 5c2 p q to the power of 4, plus rather 5c4, 5c5 p to the power of 0 q to the power of 5. Before we simplify this expansion, let's go through some of the binomial expansion identities. 5c0, that is equal 5c5 equal 1. 5c2 equal, let's do 5c1 equal 5c4, that is equal 5 factorial divided by 1 factorial times 4 factorial, that is equal 5. 5c2 equal 5c3, that is equal 5 factorial divided by 2 factorial times 3 factorial, that is equal 5 times 4 times 3 factorial divided by 2 factorial is 2, 3 factorial. 3 factorial, 3 factorial, cancel 1. 5 times 4 divided by 2 is 10. So now let's simplify it. P plus q to the power of 5. First term, p to the power of 5. Second term, 5 p4 q plus 10 p to the power of 3 q squared plus 10 again p squared q cube plus 5 p q to the power of 4 plus q to the power of 5. That is the expansion of p plus q to the power of 5 in simplified form. Let's look at the rest of the question. The probability of Dave being late for school on any day is 0.1. Let P represent the probability that Dave is late on a given day. Using the last two terms of the binomial expansion, find the probability that Dave is late no more than one time. I'll repeat, no more than one time in a school week. Let's start from the bottom. In a school week, so number of days in a school week is 5. So the sample size is 5, n equal 5. The probability, right? Let's go to that. The day late to school, the probability for that is 0.1. So if you look at the question, there are two outcome only activities, Dave late or not late. So this is falls under binomial distribution. So the question, statistics question under binomial distribution topic. So let's deal with binomial distribution to start with. Binomial distribution, before you go into binomial distribution, if Dave is k times late in that particular week in 5 days, the binomial distribution formula be like this. The probability of Dave being late k times in that 5 days week equal k. So k times Dave is late in that 5 days week. If that's so, the probability is 5, is n is 5, so 5 ck p to the power of k, q to the power of 5 minus k. This is the formula of Dave being late, k times late in that 5 days week. If that's so, the probability will be 5 Charlie ck, p to the k, and q to the 5 minus k. And if Dave is late more than, not more than, that's the question, is not more than 1, so I just wanted to use that word, not more than k times in a week. The Dave is late not more than k times in that week, how the formula would be. So the formula would be p probability x less than or equal k. So it's not more than k times the Dave is late. So that is, it can be no late at all. It can be 1 day, it can be 2 days, but k definitely is 5 or less. So therefore, just 0, 0, 1, 2, 3, 4, whatever the case numbers. So the equation, the formula would be 5, say 0, p to the power 0, q to the 5 plus 5c1, p to the power 1, q to the 4, and so on. Depends what the value of k is. So if the k is 2, we stop with these three terms, just not late at all, 1 day late or 2 day late. Or if k is 1, less than, so less than 1 or less than or equal 1, Dave is late 1 day, or Dave is not late at all. So the two terms, the two components. Right, the question is, Dave is not more than 1 day late. So the probability can be written less than 1. So what this one is, 5c0, p to the power 0, q to the power 5, plus 5c1, p to the power 1, q to the power 4. So 5c0 is 1, p is to the power of 0 is 1, q to the power 5. Q is, p is the Dave being late. The q is Dave being not late. So in other words, p equal 1 minus q, or q equal 1 minus p. So p is given 0.1. So therefore q equal 0.9. So 0.9 to the power of 5 plus, as again, 1, which is 5, we found it, p to the power 1, that is 0.1, and 0.9 to the power of 4. This one, let's look at the calculator. The 0.9 to the power 5 is 0.590 plus 5 times 0.1, 0.9 to the 4, so the answer equals 0.590 plus 0.328. The final answer 0.919. So the probability of Dave not being late, Dave is not more than 1 day late. So either Dave is no late at all, 1 day late. The probability of that combination is 0.919. Thank you.